Now let's look at procedures for non-volatile compounds. Uh, Sample preparation using standard liquid extraction. You should be familiar. So after we took a sample, it can be liquid, it can be solid. First step, we may want to remove proteins. They are making our metrics very difficult. But sometimes we can avoid it. Next step, we do isolation or extraction. So we can do single step liquid-liquid extraction or multiple step liquid-liquid extraction. Alternatively, we go over solid phase extraction, that what we'll talk later. Now, after isolation of your analyte and maybe some part of the matrix, we go for data collection and data processing. These are very primitive flow chart. So first procedure is a usual procedure for separation with organic solvent. So if I have organic mixture having several compounds, some of them are neutral, some of them are ionizable. We are adding, in this case, sodium hydrogen carbonate, so slightly basic solution, to solution of acid. As a result, our neutral compounds are staying in organic phase, but our ionizable compounds are going into aqueous phase because they are negative ions now. So ester is an organic layer, benzoic acid in form of benzoate is an aqueous. We remove aqueous layer, we have separated our neutral compound. More complex flow chart is here. I have neutral compounds, I have acid, I have basic compound. So I am adding sodium hydroxide, my neutral compounds, and my amine is going for organic phase. My acid is going in aqueous phase. After acidification of aqueous phase, I can bring my acid back into organic and then go with further analysis. Now, from here, we need to separate our neutral compounds and our amines, basic compounds. We add hydrochloric acid to this, so our protonatable basic compounds are going into aqueous phase, and our neutral compounds are staying in organic phase. Then we again neutralize, this time adding sodium hydroxide, so we have amine in our aqueous phase and bring it back into organic solvent. So as a result, we have our acidic compounds, neutral compounds, and organic compounds in organic solvent, and we can process them as we want. Usually proteins will stay in aqueous phase from the very beginning. So if I made an aqueous sample, proteins will be sitting here. Same with sugars. Sometimes I need to run continuous extraction if I want to do it multiple times. And this is how it's done with Soxhlet extractor. That's a photo of Soxhlet extractor. So how does it work? My sample is sitting here. My solvent is boiling. It's going and collected at condenser. Then it's coming onto my sample. And when it's full, it's going through this tube down to boiling device. They are two very similar cartoon animations. So again, boiling device, coming here and emptying completely. Uh, it's named Soxhlet by Franz von Soxhlet. It's an old device. Soxhlet was an interesting person who introduced pasteurization of milk and milk preserves. The design was done for removing fat from dairy. The same approach can be applied for removing from liquid from solutions. So in case if I have my solvent heavier than water, droplets of boiling solvent, for example methylene chloride, are coming here and then through here are coming back into solvent reservoir. In case of a solvent that is lighter than water, this will be water, the heavier, and my solvent will drop through the frit, will go along this volume and come back to my reservoir. As a result, it will be continuous extraction of my analyte from one phase into another.